Hello and welcome to Lesson 5.3. Today we're going to look at the Part 3 video on electron configuration. Now, if you recall from previous conversations that we've had, we hopefully know by now that ideally most electrons want to have 8 valence electrons, or they want 8 electrons in their outermost orbital or outermost shell. These valence electrons are going to help us determine the chemical properties of each individual element. If you want kind of like a shortcut or like a little trick to figuring out how many valence electrons an element should have, the valence electrons actually come from the column in which they reside in. So anything in this first column here will have 1 valence electron. Anything in this column here is going to have 2 valence electrons. This column here will have 3. This column here will have 4. This column has 5, 6, 7, and then our noble gases have 8 valence electrons. And if you remember from yesterday's video, we know that the noble gases want 8 valence electrons, and they have 8 valence electrons, which is what makes them so stable. And it's this configuration here that all the other elements are trying to obtain so that they can be stable too. Now, when we're doing our electron configuration, we can actually see the valence electrons in our configurations. So just to review or kind of practice, I guess, from yesterday, okay, let's look at the example of sulfur. Sulfur is right here, or element number 16. So with element number 16, this is going to be 1s2, because I have my first row here. I'm going to go to my second row, which is going to be 2s2. Then I jump over here to the p block, and I have 2p6. Then I jump down to the third row, and we have 3s2, and then into my p block over here, I've got 1, 2, 3, 4 elements in, so this would be my 3p4. So this right here is my electron configuration. If I want to write that as a noble gas configuration, the noble gas that comes before sulfur would be neon right here. So I'm going to write that noble gas in the brackets, and because that's in the second row, then I just have to jump down here to the third row and start with my 3s2, and then I have 3p4. Now your valence electrons in electron configuration are going to come from these, your S and your P exponents or superscripts. Okay, so if I go 2 plus 4, this is going to give me 6 valence electrons. And if you notice, sulfur right here is in the 6th column over. We kind of ignore these elements in here, and we'll talk more about those later. But for valence electrons, we see that that column has 6 valence electrons. Now, when we go to look at cesium, for our second example, cesium is all the way down here. Now, because there's a lot of elements before cesium, what I'm going to do is I'm going to go directly to the noble gas notation. So cesium is element 55, and the noble gas that comes before cesium is xenon. So I'm going to write that in my brackets, and then I see that cesium is in the 1, 2, 3, 4, 5, 6th row, and it's in the 1s spot. So this right here is my shortened notation, or my noble gas notation for electron configuration. And notice here, I have 1 valence electron because of my exponent right here. And if you notice, cesium's in that first column, which confirms that I should have 1 valence electron. Once we understand how to calculate our valence electrons, we can go ahead and create what we call electron dot structures. Now, electron dot structures consist of an element symbol, and it's going to be surrounded by dots, and those dots are going to represent our valence electrons. So these are the electrons, keep in mind, the valence electrons. are what are involved in the forming of chemical bonds. And we can actually use electron dot structures to help us see that when we get to that point. Okay, so what we're going to do is we're going to place one dot on each of the four sides, okay, and you can start on any of the four sides, it doesn't matter. Okay, the only thing you have to remember is that all single spots have to be filled before you can start pairing them up, okay, because we cannot have any more than 2 electrons on any given side. So if you pull up the periodic table that I shared with you and we look at carbon, carbon has 4 valence electrons. So what that means is I can drop 1 electron on each side. So this right here is what we call a dot structure or an electron dot structure. And this ultimately just shows me that I have 1, 2, 3, 4 valence electrons. Now if we do another example, and again, you'll have to look at your periodic table. Let's look at the element bromine. Notice that bromine is in column 17, okay, which means it has 7 valence electrons. It's the column right before the noble gases. So in this case, I'm going to have to place 7 valence electrons. So I start out by putting 1 valence electron around each side. Then it can go ahead and start pairing up. So I've got 4, here's 5, 6, and 7. And again, I'm not going to put any more than 2 electrons on each side. And you can see on this side right here that we have 1 valence electron short of being a noble gas. If we look at something like beryllium, which is Be, or element number 4, beryllium is in the second column, which means it has 2 valence electrons. And if I'm going to do 2 valence electrons, you can draw a single dot on any 2 sides, and it doesn't matter which 2 sides you use. You can only put 1 dot on each side though. Okay, so these are a couple different ways, or a couple different examples of electron dot structures. And our final example for this unit says to draw an electron dot structure for the element oxygen. So the first thing I'm going to do is I'm going to look at my periodic table. Oxygen is in column 16, which tells me that it has 6 valence electrons. So that means I can draw 1, 2, 3, 4, 5, 6. And again, it doesn't matter which sides you double up. It doesn't matter where you start. You just have to have 2 sides with 2 electrons and 2 sides with single electrons. Fluorine is in column 17. It's the column right before the noble gases. So this column has 7 valence electrons. And so I'm going to show that again by showing 2 dots on 3 sides and 1 dot on the other. Nitrogen now is in column 15, or it has 5 valence electrons. So for this element, I'm going to go 1, 2, 3, 4, and then you can double up on whatever side you want to, and I'll just double up right there. So this is 5 valence electrons. This is all I have for the 5-3 part 3 video. Please let me know if you have questions. Otherwise, I hope you guys have a great day, and I will see you tomorrow.